Good day, students. On this clip, we're going to go over natural logarithms and its inverse e. We're going to evaluate some expressions, do some calculator approximations, and then solve it. Okay, so let's write down the title of this lesson. Natural logarithm and e. Natural logarithms, which is written as ln and e. So these are inverses of each other, okay? E is the Euler number, the exponential number, and ln is the natural logarithm. Alright, so we're going to start out by evaluating some expressions with the aid of our calculators. So we're going to evaluate number 1, the natural logarithm of 576. Okay, so fire up your calculators. Let's see what that is. For that, so we just look for the ln button in your calculator. Most scientific calculators have that as a standard button. Okay, so ln of 576 is 6.356. 6.356 is the approximate value. 6.356. All right. Okay, number 2. What is the natural logarithm of negative 7.2? Let's try that out. Natural logarithm of, this is a negative negation there right there, 7.2. Answer, non-real answer to go to. So, you cannot take the natural logarithm of a negative number because it's out of the domain. All right. So in this answer, there's no solution. All right. You can only take the natural logarithm of numbers that are bigger than 0. That's the domain of the natural logarithm. Okay. The negative numbers does not work. Let's try another one. Let's try the anti-natural logarithm of 0.375. Antilog is the inverse of natural logarithm. So what is the inverse of natural logarithm? The inverse of natural logarithm is e. So this is another way of writing. This is the same thing as e to the 0.375. Okay? So that's what we're going to enter in our calculator. So let's enter it. So second function e, let me clear this out. Second function e to the 0.375. Alright, so if we do that, enter 1.1455. Okay, so it's 1.1455. 1455. This is actually an approximate result. It's not exact, so let me take this equal out of there, make it an approximate value. Okay. So there you have it. If you want to check if my answer is correct, I can just take the logarithm of the natural logarithm of my answer, and then we should end up with what I started with. So this shows that my answer is correct, because when I took the natural logarithm of my answer, I ended up with what I started with. Okay? So e and ln are opposites, or inverse operations. Alright? Okay, so keep that in mind for the classwork. Let's move on to conversion. Okay? So we're going to convert each base, I'm not writing well, convert each base to natural logarithm. Okay? Alright. Number 4. We have log base 3 of 7. So this one is simply ln of the number divided by the natural logarithm of the base, which is 3. Remember, there's an imaginary e right here, right? Put an e here. Those are imaginary. You don't put them. You just have to write it like this. That's good enough. All right, that's a change of base formula. So to do this, you just simply take the base, put it on the bottom, and then take the number, put it on the top. And whatever target base you want, it could be ln, it could be log 5, log 7, That's what goes on the left side. Alright? Let's try another example. Let's say we had number 5 wanted to do log base 5 of 4. This one is going to be the natural logarithm of 4. The number goes on the top and the base goes on the bottom, ln 5. Alright? How about a general rule? Let's formulate an expression for a general rule. Log base x of y. This is simply going to be the natural logarithm of the number, in this case is y, divided by the natural logarithm of x. Okay? So there you have it. Alright, now we're going to try out some problems on solving logarithmic equations. So write down the title of the section of examples. Solve each equation stating the exact and approximate solutions. Okay. So this, when you're doing these problems in the board work for today, I would like you to give me the exact answer and also the approximate solution. Okay. All right. Number 1. Let's do. Number 7. E to the 3x equals 33. Now, when do you use natural logarithm? Whenever you're dealing with base e, any other base. Whenever you're dealing with exponential equations involving base e or any other exponent, especially the ones with different bases. So this has base e, so the best one for this is automatically natural logarithm. Okay? So what I'm going to do is I'm going to take the natural logarithm of both sides. So ln of e to the 3x, and on the right side, ln of 33. Okay? Remember, ln basically is log base e, right? Like you have an imaginary e right here, and you know how that cancels with that, right? So that's why we chose ln. So what's going to happen here is that this and this cancel each other out, and then we're going to have 3x equals natural logarithm of 33, divide both sides by 3, and then you're going to have x equals the natural logarithm of 33 divided by 3. Now the question is, can I divide this 3 into this 33? And the answer is absolutely not. You're dividing the natural logarithm of 33, not 33, by 3. Okay, so you must take the natural logarithm first before the 3. You divide by 3, alright? So keep that in mind. Don't reduce. That's wrong. So if you did this, ln 33 over 3, if you divided this to become ln 11, that's wrong. You can't do this because ln is inside 33. 33 is inside ln. You have to go through ln first before you get to 33, okay? So this is your exact result. And then your approximate result is, your approximate result is going to be, let's see what the calculator says. Natural logarithm of 33 divided by 3. Answer is 1.1655. So just give me 4 decimal places, that's sufficient, okay? So 1.1655. Okay? So there goes your exact, and this is your exact, this is your approximate solutions. Alright, with that in mind, let's go ahead and try another example. Number 8. Write this down. We're going to do 4 to the x equals 7. Now, this one you have only one exponent, okay? I can eliminate this using log base 4, but I can always also use natural logarithm. Natural logarithm works for all exponential equations regardless of the base, okay? So I want to use natural logarithm here, since that's the section we're doing. So in this case, we're going to go ln of 4 to the x equals ln of 7. What happens here is that this doesn't cancel out because we're taking natural logarithm. But what this enables me to do is I can take this power and toss it to the front. So this becomes x times the natural logarithm of 4 equals natural logarithm of 7. Now I can divide both sides by a natural logarithm of 4. ln 4, ln 4. And then we're going to have x equals natural logarithm of 7 over natural logarithm of 4. This is my exact answer. The approximate answer is going to be natural logarithm of 7, please close that first, divided by natural logarithm of 4. Final answer is 1.4037. 1.4037. Okay, so 1.4037. There goes your exact and approximate results. Okay, let me show you a different way of doing this same problem. Let's say we had 4 to the x. Since this has only method 2, since this is just one exponent base 4, right? And if I wanted to get rid of just this one exponent on the left side, I can take log base 4 of 4 to the x equals log base 4 of 7. Alright, and then on the left side, these two cancel out. Bam, bam. And you have x equals log base 4 of 7. Remember the change of base formula we just went over? This is the same thing as you take the top ln of 7 over, and you take the base and put it on the bottom ln of 4. That's exactly what we have here, okay? So we can see that natural logarithm always solves all exponential equations, but log with a specific base works only if you have one exponent with that base on the equation, okay? So let me show you an equation where this is exclusively for natural logarithm. What if I had something like this? 4 to the x plus 2 equals 3 to the x, so 3 to the x. So in this problem, you see that the bases are different. So if I did log 4 here and log 4 here, I'll have problems. Or log 3 here, log 3 here. None of them can cancel out once. So this one, different bases, ln is the best, is the quickest way of doing it. So I'm going to take natural logarithm of the left side, 4 to the x plus 2. And then on the right side, natural logarithm of 3 to the 3x, 3 to the x. So this enables me to ground the power, so to speak. So this one becomes a coefficient, and this one right here also becomes a coefficient. So we're going to have x plus 2 times the natural logarithm of 4 equals x times the natural logarithm of 3. So when you distribute this natural logarithm of 4 to both terms, on the left side, you're going to have x times the natural logarithm of 4 plus 2 times the natural logarithm of 4 equals x times the natural logarithm of 3. So I need the terms of the x's on one side so that I can isolate the x's. So I need this one right here, this term, and this term on the same side, okay? So how about I just move this one to the right side? How do I do that? Subtract x log 4 from both sides. And then your final answer, you're going to have, it's going to become 2 times the natural logarithm of 4 equals x times the natural logarithm of 3 minus x times the natural logarithm of 4. Okay? So I can take out x from these, so I'm going to have 2 times the natural logarithm of 4 equals, I take out x from these two, x times the natural logarithm of 3 minus the natural logarithm of 4. Alright? And then to finish this off, I gotta get x isolated, so I'm going to divide both sides by what x is being multiplied by. So divided by ln 3 minus ln 4, and then ln 3 minus ln 4. These two sides cancel, this cancel out, and then we're gonna have x equals 2 times the natural logarithm of 4, 2 times the natural logarithm of 4, divided by the natural logarithm of 3 minus the natural logarithm of 4. Okay? This right here is your exact solution. Please don't try to cancel anything because you have a minus here. You're going to ruin the problem. So let's find the approximate value. Okay, so we're going to have 2 times the natural logarithm of 4 divided by parentheses for the denominator because you have multiple terms and you want them grouped together on the bottom. So you have to put that group in parentheses there. Natural logarithm of 3 minus natural logarithm of 4. Close that, close the denominator. Final answer is negative 0.6377. 6377. So so your approximate answer is negative 9.6377. Okay, 9.6377. So there goes your answer. All right. So thanks for paying attention to this video. Now we're gonna go ahead and start on the board work problems.